Hi everyone. Thank you for joining me in today's sessions. I'll start off the sessions with something more fundamental. So my name is Sebastian, and I'll be going through the topic of not all databases were created equal, and how to choose the right database for your workload in 2024. So a little bit about myself. I know we introduced. I've been with Amazon for more than 5 years. I work in this role for 3.5. I work daily. I interact daily with startups. So the early stage startups, the late stage startups, and help them to develop their solutions in AWS, as well as supporting them in their journey with AWS. So to get things started, I'd like to ask the audience, do you know why you choose your database today running your workload? Does anyone just want to share why you choose certain database for your workload today? Okay, yeah, it's fine. So one of the things that I ask often when I ask my customers is, why do you choose this database? Usually I get answers like, because we heard X is the best new thing. This is what we have paid for. You have a license and you're using it. And one of the most common one is actually this, because we know how to use X. And to be frank, all these are valid answers and all these are great answers to why you choose your database. Perhaps what I was looking for was along the line that you should be picking a database because it supports what my application is designed to do. What this means is that the database not only needs to support your functional requirement, let's say your CRUD, your CRUD, create, read, update, delete, but it also needs to support your non-functional requirements. An example would be like 2,000 transactions per second, right? So those are non-functional requirements, but it's necessary to run your business. So for example, when evaluating a database, how I see this is that we first look at the application, identify the use case, and then look at the type of data that you are storing and answering questions such as, what are we going to do with those data? And then that's where I will pick the database. It sounds very common sense, but sometimes when you work with startup customers, there are certain contexts and constraints, and I fully respect that. So a bit more about myself. Prior to this, I spent over 8 years working as a software engineer. I worked with 2 of the early stage startups back in 2011, 2013. One of the largest, proudest thing that I had was with Shopback, where we were a 4-man team. One of the mistakes I would say that I learned early is that picking the right tool for the right job is extremely important. So one example is that in Shopback, we picked a relational database at the beginning, knowing that we are running an early stage startup, knowing that we don't have a product market fit, it became a bit harder to move fast. And one of the most advantage of a startup is to move fast and break things, right? So maybe not the break things part, but move fast. And with a relational database, it constrained our ability to move fast. And every time a new feature requests get exponentially harder to build. I mean, later on, we realized that we took a step back, we refactor, we make it into a non-relational database, but that's a different story. So this is today's agenda. What are modern applications? Why consider purposeful built database? And how do we pick the right tool for the right job? A little bit of history. I know you guys probably know this very well. So back in the 60s, 70s, mainframe was the predominant way of building applications. This lasted until the 80s. So when client and server was introduced, this changed the way applications were built. Apps started to become more distributed in nature, but underlying the data structure itself, the data model were predominantly structured, and the database was monolithic. Then came the internet. So in the 90s, the internet came. 3-tier web applications was the most popular architecture emerged, and client and application code became more distributed. But one thing remained the same. The database remains a monolith. The thing I would like to point out here is that if you think about it, for almost 3 decades, people have been building applications on a single monolith. So if you have talked to people around, you'll be, one of the most common response that you get is that, hey, I've been building apps, right? So I've been building apps in the 90s, in the 20s, even in 2010s, even 2023. And all these apps has been built against one database. So why should we split the database? So what has changed? Microservice, one of the big change. Fast forward to today, businesses want agility. Business wants to move fast. It doesn't mean squeezing 9 months of development into 1 month, but what this means is building a product that's much more suited for your customers. And microservices helps company and businesses to move fast. And one of the positive side effects of breaking down these large applications into smaller services is that it allows the developers to pick the right tool for the right job. As a result, they can avoid a single overburdened database with one storage engine and one compute engine trying to handle every single access pattern. So diving deeper, what contributes to this change? User growth is a common KPI for businesses, and the cloud global reach enables businesses to touch millions of new customers. The next one, data volume. Businesses are capturing more data. We talk about terabytes, we talk about petabytes. This data not only helps you to sell better, but also creates new opportunities such as new business insights. Two things, at least in the local markets, locality, especially in ASEAN, every region, every country operates very differently. This is very different from, let's say, in the NAMIA regions where you have Canada and US. The markets are very similar. They tend to speak the same language. In ASEAN specifically, the Singapore market is very different from the Indonesia market compared to the Thailand market. So I work in an ASEAN team. We are having an offsite this week, and you can see the problems and challenges that each market has is very different. Performance, with the growing growth of users, businesses don't want to dilute the user experience, right? So one of the things that our previous CEOs said, I think it's very beautiful, Jeff Bezos, he often says that customers are always beautifully, wonderfully dissatisfied. You give them 2-second latency, they will ask for 1 second. You give them 1 second latency, they will say, I want microsecond. They are always going to find something better. And if somebody's going to do it better, they will switch. So businesses are always adopting new distributed models for developing applications because it drives agility, it drives innovations, and it drives efficiency. The one-size-fits-all approach of using, let's say, a relational database is no longer working as well, right? So it's still working. You still can build your apps on one relational database. It's just not working as well. So that to say, now I have hundreds of databases out there. You can see in the market. You can just Google for database. You can see tons. How do we know we are picking the right tool for the right job? And that's where I come in. So here, one of the mental models that we do in AWS is to categorize them. So this is a simple mental model to help us reason how builders use different systems. So I'll go through the top 4 use cases, the top 4 most popular category. And of course, we will start with relational. So relational database, as most of you know, as most of you are expert of it, are all role-oriented and developed in the 70s. They are optimized for storage, as storage was expensive back then. So to give you a bit of context, in the 1980s, a 10 megabyte hard disk cost about $2,495. Adjusted for inflation, that would be $7,210. That's for a 10 megabyte hard disk. Do you guys want to guess how much is a 4 terabyte hard disk today? I just bought a 4 terabyte hard disk. Do you guys know how to know? That's too cheap. It's about 70 US dollars, about 100 Sing dollars. That's 4 terabytes. I bought a 4 terabytes for 70 US dollars. Relational database breaks data over tables. Most of you know this is normalizations. One of the key things about normalizations is to save on storage, right? They implement referential integrity, which means that you can't remove data that is required for another piece of data. And most importantly, it provided strong consistency that is especially important if you need to support transactional across tables. So I hear a lot of finance companies. I think this is one of the most important things that you want. You want strong consistency. So as a builder myself, as a software engineer myself, based on these tables, if I want to find out how many doctors are affiliated with a particular hospital, or if I want to find out how many doctors visited the patients, this is easily achieved in a relational database. Maybe a quick poll of hand. How many of you have seen a query that is 1 pages long for the data teams? 1 pages long query. One pages long. Yeah. So in fact, I wrote those when I was in Shopback. It's not the easiest to read, but unfortunately that's the truth. If you want to do relational database, sometimes you have to write that 1 pages long query. I mean, this is not 1 pages long, but you get a gist, right? So why we have to write that 1 pages long query is because sometimes we are overloading a system that is there, and because we didn't pick the right tool for the particular database, for the particular use case. So now onto the second most common category, the key value database versus and the document database. I'll speak about the difference. So unfortunately, I'm from AWS, so DynamoDB. I will use DynamoDB as an example. In DynamoDB, you have a table, and you have items inside, easy. And each item contains attributes. And one of the things in DynamoDB is that you have a mandatory field called partition key, which is used for the key value access pattern, right? And you have an optional field called sort key that enable rich query capabilities, such as sorting and counting. But this is roughly how a key value database looks like. There's a key you access using the key. So let's say we were building a video game app and we didn't know how many users we're going to get. It could be 10K, it could be 100K, it could be 10 million. But what we know is that we needed consistent performance, no matter the size. It doesn't matter the size, we needed consistent performance. The key here is consistent performance. So if I wanted to write a query that gets me that current health of a player in real time, this is a simple query and a simple get, and it works extremely fast with a key value database, right? This query gives me the data I want. Very fast. In software development, software engineering world, this is O1. Based on the O notation complexity, this is O1, key value pair. Or if I want to get all the information on the gamer, this can be done with a single API as well. So unlike the previous one, we have a lot of joins here and there. This is a very simple query to write. The advantage of a key value database is that I will always get consistent performance regardless of the size of the database. Okay, now move forward to 2000s. 2000, there was an explosion in a certain technology, or rather certain format. Do you want to make a guess? So XML was before that. So JSON was the one, right? So I mean, I'm pretty sure you guys heard about SOAP, XML. That was before 2000. After 2000, JSON was the de facto for data exchange between clients and apps. However, when developers want to persist JSON object to these, they had to translate back into relational model. And this provided what a phenomenon called impedance mismatch. That's where document database comes into the scene. So in document database, the document becomes a first-class citizen. No longer a second class, no longer a third class, first class. You store the documents, you query the documents, and as well as its attributes in the database. So for use cases that do not require referential integrity and transactions of a relational database, the document database became a very intuitive, productive way for developers to work with data. So for many developers, they do not need to think in terms of normalizations. Instead, in this world, it's denormalizations. You want the data to be self-contained inside a document. So as data and metadata are stored together, documents are self-contained. And with that flexible schemas that you see here, structures of data can look different between documents. So nevertheless, as these documents are self-contained, you expect duplications. But that's okay, because I just talked about 4 terabyte of data, 4 terabyte of hard disk costing $70. That's cheap. So storage has gone down, and this makes practical sense to use something like document database. That to say, not all workloads should run on document database. One particular challenging workload will be analytics. Because the schemas are different between the documents, there needs to be some pre-work required to reason about the schema, which is why pick the right tool for the right job. Okay, so moving on, graph database. How many of you have used graph database? Okay, great. So not a lot. It's a very new field, I would say, comparing to the rest of the database. Graph database is pretty new. Graph is a relatively new option. It was designed to focus on the connections between the data items, and it's great for social networking, social networks, recommendations, fraud detections. I know there's a lot of fraud detection use cases here, and product catalogs. So allow me to maybe start off with the basics. To give you an example, if we want to model out a recommendation engine, so in this case, we have Bill, which is what we call the vertex, who purchased a product on the line. So the line itself is the age, right? And follows spots. So in another space, we have Kevin, who purchased a product and also follows spots. Okay, to make it a bit more complex, now we have a new user, Sarah, whom has an interest in sports. What do you think we can recommend? Right, so based on this relationship, you can see that it's obvious we can recommend the same product to Sarah. And this is what graph is all about. It's all about relationship, understanding the relationship between objects and then deducting something from that, some insights from that. Okay, so remember the first page where we have a relational database, you write long query, and you can see the difference here. By mapping it on the graph database, the query itself is very easy. One-liner, less than 1 page, or even less than half a page, you get that result. So I'd like to give you another example, just to solidify this understanding. So imagine friend recommendations. So I believe most of you know that social media network is actually not looking at your address book, right? So they don't have access to your address book. But what they do best, what they do really well, is that they are always recommending you to friends that you sort of know. But how did they do that, right? So in this case, when a new user, Mary, join and friend with Amit, the graph shows that Amit knows Kevin, and Kevin knows perhaps should know Mary. Right? So this is how friends recommendation works. LinkedIn, Facebook, they are really good at this. I believe, I strongly believe they don't have access to my address book, but they always make the right friend recommendations. And this is the technology behind that. So imagine this is only 5 vertices. Facebook, LinkedIn, they have more vertices. They can make better recommendations. This can be done. So I'm not saying that this can't be done in other database, right? So other database can do it. Relational database can do it. NoSQL can do it, document can do it. But if we map it on graph, this query will be very easy. So 4-liners. You get to know the final friend that you can recommend to marry. So same thing, same as what I said earlier, pick the right tool for the right job, right? So graph database, great for understanding relationship. So this slide shows how different use cases affect the type of database you choose. So on the left, a relational database, it's used to help answer questions for a business process, such as how many employees has the required skill set that are acquired before 2000, right? While on the right, a graph database is used to answer questions about who are the employees that have a high potential to become a super spreader during a COVID or during a pandemic. And that's exactly one of the use cases that I work with a customer on mapping their relationship onto a graph database because they wanted to provide the government on those users who are the super spreader. So now that we have a little bit of understanding on how things works, and you want to learn a bit more, you can visit this workshop. This workshop is called Database for Developer. It's created by me and my team. We built this workshop not only to help you to understand purposeful built database, but also teach you how to break up monolithic database to each individual database with minimal downtime. So we talk about microservices. A lot of times we talk about on the application layer. Rarely, I've not really seen it a lot, talk about how to break down the monolith database into its own, like CDC as a pattern. It's known, but it's rarely taught. So in this workshop, you start with an awesome pet. It's called Awesome Pet with a simple 3-tier web applications. This is a monolith applications with a single MySQL database. And then later on, we will explore patterns like the CDC or a simple DAM to 4 separate microservices, each using a purposeful built database to support their specific business use case. So what we have learned, we talk about modern applications requirements that has changed over the decades and why choosing the right tool for the right job is important. And as a general rule of thumb, we should start from the applications. I know sometimes it's difficult, but it would be great if we could start from the applications and work backwards to choose the right database. Lastly, if you want to learn more, you can use this workshop as a jumpstart. If you need help, let me know. Okay, so now to the point of why you should run these critical workloads on AWS, right? So why run this? Databases are mission critical workloads. So why should you run it on a trusted provider like AWS? So a key important consideration here is that with AWS, you control where your data is stored. We don't have access to it, and your organization has visibility in what is consumed at any given point of time. So also importantly, here in AWS, we provide you with a broadest and deepest compute platform to choose to run your database. Specifically on Aerospike. Aerospike on AWS is a natural fit. One of the key innovations that we have today is what we call the Graviton instance. Graviton instance is a ARM architectural instance built purposefully for AWS by one of the companies called Annapurna Labs. Graviton with Aerospike help you to reduce your total cost of ownership and improve performance to meet your SLA. So on efficiency, I think this is one of the key things that we want to talk about with sustainability. We want to be able to run your workload at a much more efficient manner. And Graviton is one of them. So when we factor in the carbon intensity of consumed electricity and renewable energy purchases by AWS, the same workload is run at 88% lower carbon footprint. So when launched with Graviton, you get better power efficiency of 3.5 times performance over watt when compared to a similar instance type. All right. So that's all from my session today. So my name is Sebastian. I hope to speak to you soon. If you can drop down my email address as well, so feel free to email me. I work with the Singapore startup ecosystem, regardless of fintech, health tech, whatever. I work with the range of them. Right?
Thank you. Thank you so much for that insightful session, Sebastian.